Okay, we're going to look at many types of linear systems. And essentially there are three major types, okay? First one we're going to look at is we're going to solve for these two equations. We're going to solve for the coefficient, because k is going to represent some number in front of x, so that there are an infinite number of solutions. Okay, infinite number of solution means the two lines are actually the same, so they're identical. Okay, so maybe the easiest way to do that is to set both of them into our slope y-intercept form, our y equals mx plus b, so that we can have a better view of it. Okay, so I'm going to take our equation 1 and I'm going to set it equal to y. And then after we do that, you'll notice that there's a really fast way to go about doing this. And we'll go back to that. So we have 3x minus 6y is equal to 12. The goal is to get y by itself. So the first thing we want to move is 3x to the other side. When it goes over there, it becomes negative. So we get negative 6y equals 12 minus 3x. Okay. And again, we got to get y by itself. So we need to divide everything on the other side of the equation by negative 6. So that'll give us y is equal to 12 divided by negative 6 is negative 2. Negative 3, okay, and we won't worry about the x, divided by negative 6 is positive 1/2 x. Okay, so though they're kind of written in different order, this is our slope and this is our y-intercept for equation number 1. Equation number 2. We have kx, gotta learn my alphabet, minus y equals 2. Again, the goal will be to isolate for just y. And when we mean just y, we mean positive y. So let's move kx to the other side. Now I want you to think about this. If I were to move positive kx to the other side, what do you think it would become on the right side of the equation?
A negative.
Yeah, so how would I write something like that? Do you know?
Minus kx.
Yeah, that's right. You just put a negative sign in front of the kx because that's what we moved. Great. The next thing we want to do is we still want to get y by itself. There's technically a negative there. So if there's a negative there, you can almost think of it like a negative 1 times that. So in other words, what we kind of need to do, and there's two ways we can do it, we'll kind of mimic the way we did in the other. We divide by negative 1, but we technically could have also multiplied by negative 1, but no matter. When we divide negative 1 by negative 1, we'll get positive. So we're going to have positive y, which is the same as our first, is equal to 2 divided by negative 1 is negative 2. And k, or negative k, again, we won't worry about the x, negative k divided by negative 1 will be positive k x. Okay? So because we've set them both equal to y, we can see the similarities. And remember, we need to find identical equations. So in order to be identical, let's double check that everything's going to work out. Well, we have a negative 2, we have a negative 2. What's the coefficient I have in front of x?
A half.
Half. So what does our k need to equal to be an identical equation?
A half.
That's right. K needs to be 1/2. Okay. This is one way of doing it. Another way we could do it, if we were intuitive enough, is similar to elimination. Okay. Because I knew they had to be identical, I means I need the I need to find the common value between these numbers. Okay. In other words, this equation is this equation. I just got to figure out what to multiply up by or divide down by to turn these coefficients to these coefficients and this constant. Since multiplication tends to be an easier idea, what would I multiply 2 by to get to 12?
6.
6. So let's test that to make sure that works all the way through. Does negative y times 6 take us to negative 6y?
Yeah.
Okay. So that means I have to take k and multiply it by 6 to get 3. Might be tough. Can you think of a number and multiply 6 by to get 3? Could be tough off the top of your head. So multiplying up, we know the number is going to be 6. We figured that out. What's the opposite of multiplying?
Dividing.
Dividing. So in other words, I should be able to divide by 6, 12 to get 2. Did that work?
Yeah.
Yeah. Can I divide negative 6y by 6 to get to negative y?
Yeah.
Okay, so here it is. If I divide 3 by 6, what do I get? What is 3 divided by 6. What does that equal to? I'm going to take a calculator out and test it. I'll bring it up on this one too, just so we can see. 3.
0.5.
0.5. Oh, perfect. Now, is that the same answer that we found before?
We got a half before.
Yeah. And what is a half as a decimal?
0.5.
Yeah, they're identical. Just this one came in fraction form and this one came in decimal form, and it doesn't really matter, okay? Now that we have that one, those are two identical lines, right? If we were to show that on a graph, it would look kind of like this. The first one was 3x minus 6y equals 12, and my other one was, and I'll show it with k. This will work out great. 3x minus y equals 2. Get a slider for k. Oh, wonderful. Adds on this. Okay. So if k was 1, we'd only have one solution. And our y-intercepts are the same. Do you notice the y-intercepts are the same? And as I move my k around, I really only have one solution no matter what I kind of do with it. I'm going to jump past a point here. See, I still only have one solution. But there's a value I get to where they end up being the same line. And that value is what? When k is what number?
0.5.
0.5. See, they're the same. And now they have an infinite number of solutions. These are all identical. So if k was any other number, we would only have one point of intersection. Because our y-intercept's the same, we actually can't have one with no solution. Because the only way to have no solution, okay, and we'll kind of bring up two other ones, is if we have y equals 3x minus 2, y equals, the slopes have to be the same. And you notice in our first one, when the slopes were the same, they have an infinite number of solutions. Okay. There we go. I'll turn these two off for a sec. Notice they have an infinite number of solutions. Okay. But if I have a different y-intercept, turn these guys back on, I have 0 solutions because they're parallel to each other and they go this way forever and they never get closer or farther from each other. There's always the same distance between both of them. Does that kind of make sense?
Yeah.
Okay. So there we go.